We have the second law of thermodynamics and engines of cognition.
Yes. All right. When did you read these?
Last week.
I read this yesterday, and I was like, all right. I can. It says at the top like 11-minute read. I'm like, I can read this. I can take some notes. Obviously, it's going to take me a little longer because it always does when you're trying to analyze and take notes. But I'll be in bed by midnight. Listeners, I was not in bed by midnight. I spent a lot of time trying to grok the second law of thermodynamics and engines of cognition. I think I'm just too dumb for this post because I can follow each of the individual arguments that he makes in it. Each paragraph taken on its own makes sense. I can digest it. I got it. But like, I cannot draw all the different parts of it together to form a coherent story, a coherent line of thinking, just like a coherent whole. It doesn't work for me, and that worries me that there's some sort of, it's like the when you put a whole bunch of drops of water together and all of a sudden you're shocked that there's fluid dynamics, or when you put a whole bunch of neuronals together, all of a sudden you're shocked that there's consciousness. Like this, I was not able to integrate all of the parts of this. And so much like the proof that shows 1 equals 0, because you cannot see all the parts of it and see where the error is, I'm worried there might be a divide by 0 error somewhere in this post that I cannot see because I cannot grok it all.
Speaking of not being able to see something, I need to just clarify something.
Mm.
The last episode that we released was 202, the Center for AI Policy, right?
Yeah.
In that episode, it says the next sequence posts are searching for Bayes structure and conditional independence and naive Bayes.
What the fuck? Did I read the long ones?
One of us did. Either you posted the wrong ones or read the wrong ones. Because I read the other ones. I didn't read this one.
That is shit. I'm sorry.
Oh, I mean, I don't. It's not a big deal. Perpetual motion beliefs. I tell you what. Why don't you explain this one to me? I remember perpetual motion beliefs. I think.
Okay.
So I read the wrong 2 episodes or wrong 2 posts because the wrong 2 ones are posted in the episode description, and neither of us remember what we said we were going to read. So good luck to everybody. But this week we are talking about the second law of thermodynamics, engines and cognition, or engines of cognition, and perpetual motion beliefs is the second one. And I remember the second post. I don't remember the first from when I read it before. And Enosh is going to try to explain it to me, and I'm going to do my best to learn as quickly as possible.
Okay.
All right.
Alrighty. So let's see how I can do this. The first thing I drew out of it at the top is that the first law is the conservation of energy. Energy is conserved in each individual interaction of particles. And thus, by mathematical deduction, no matter how large an assemblage of particles may be, the same applies. So unless you can explain how one wheel violates the laws of physics, an assembly of wheels can't do it either. Does that make sense?
Yeah, so far so good.
Okay. Just real quick to blow my own horn, not to blow my own horn, to be sort of an ass about the consciousness thing. If one neuron can't like tap into a magical consciousness thingy, and a whole assemblage of them couldn't either, right?
I was going to say yes, except for maybe not. To be clear, I'm not positing that there is some magic, other thing that, is above and beyond physics that comes out of enough neurons. I'm just saying that there's something to that bundle of neurons and what's happening inside of it that is different than what's happening inside of my phone.
Oh, definitely different from what's happening inside of your phone, but what's happening inside a bundle of neurons can be reduced to what is happening to each individual neuron and the effect it has on the individual neuron it is connected to, right?
Yes and no. I'm not a big fan of the word emergence, but there's something about, like a single atom or single molecule of water not telling you everything there is to know about steam, ice, and, sublimation.
Okay, yeah.
Maybe if I knew all the other laws of physics, I could deduce that from a single water molecule, but
right.
Since I don't, and neither, and analogously, neither do I know that about the brain.
Yeah.
I think that there's the word emergent properties there is one should be mindful of, but is sort of appropriate.
All right. That makes a lot of sense, actually.
All right. Let's keep rocking.
All right. Keep rocking. Next thing he says is that the first law cannot prohibit converting heat into work. You can, in fact, build a sealed box that converts ice cubes and stored electricity into warm water. He says it isn't even very hard, which is true. So it couldn't violate conservation of energy as such if you did it the other way around. A box that turns warm water into ice cubes plus stored electricity. He says that is prohibited by the second law of thermodynamics. Second law is essentially Bayesian in nature. In the development over time of any closed system, phase space volume is conserved. Do those words mean things to you, Stephen?
I would have to squint and make up a definition, but I'll let you go ahead and tell me.
It draws an intuitive line right back to the first law where the combined energy of a system is conserved. The total energy level is conserved. Here it's the total volume being conserved. And like, it just feels natural. It feels mirror-y. There's a symmetry to it that tickles this is what the universe is right and should be, and it is good part of my brain, which I tend to trust a bit.
Yeah, no, I can take it.
All right. So, okay, explaining phase space. Let's say you're holding a ball high above the ground. We describe the state of affairs as a point in multidimensional space, at least one of whose dimensions is height of the ball above the ground. I believe we talked about this in earlier posts. So phase space in physics speak means that there are dimensions for the momentum of the particles, not just their position. A particle would have 3 dimensions for its position and 3 dimensions for its momentum. The 3 being the X, Y, and Z axis position and X, Y, and Z axis momentum. As the example going back to the tennis ball thing, the phase space volume would be the height is 10 and the energy is 0, so it has a certain volume. As the distance to the ground decreases, the velocity relative to the ground increases, and so while one is going down, the other one is going up, so the total volume is conserved in this multi-dimensional graph that we're thinking of. Does that make sense?
It's starting to fuzz a bit. It seems needlessly convoluted way to describe what's happening there. I would talk about it in terms of I think this could still be talked about in terms of conserved energy. Like the ball at time 0 has a lot of potential energy but no actual energy, right? Because it's not moving.
Mm-hmm.
And at time 1 it's moving, so it has less potential energy because it's already on its way, but it has that the energy is in its motion.
Mm-hmm.
But calling this phase space volume is still not quite clicking for me there yet.
Okay.
But I don't know if it needs to, because I don't actually know if that's the point of this post.
I don't know either. I do know that the phase space concept is pretty darn important, both in this particular example and in other things that are talked about. The idea, I think it was in cluster space that we were thinking of, where each attribute could be seen as one dimension, like the yellowness of a bird. And something that is really high in yellowness might be sticking way out of the main cluster if the birds typically are more like greenish than yellowish. And you can think of it like as a volume where the things by the typical are closer to the center of the object. Do you remember that kind of thing?
Yeah, totally.
Okay.
That stuff lands for me. But what is that relates to things in concept space? What is, so I guess you're still trying to convey to me what phase space is.
Mm-hmm.
Okay.
And phase space would be like, you're thinking about not the concept like yellowness, but a concept like height above the ground or velocity relative to the ground as part of the phase space. And I mean, those are my...
Okay, yeah, that's clicking. Great.
Yeah. And so then as those change, they always change in a way that conserves the volume, the total volume. There's a couple things in here where he shows what would violate this conservation of momentum, which I didn't pull out because it has to do with states changing and having various graphs that don't work well over an audio medium. I guess I'm going to have to go past that because I do not know how to explain it to you. Yeah, I'm going to leave it at there because the phase space is pretty important, but I'm not sure why exactly. And this is part of the confusion I talk about later. I'm going to skip ahead now to temperature, how that has to deal with uncertainty. If the only thing you know about a glass of water is its temperature, then you are more uncertain about a hot glass of water than a cold glass of water. Real quick, do you have a guess as to why?
Hot water has more stuff going on in it than cold water?
Yeah, exactly. Not all the molecules in hot water are traveling at the same speed. In fact, in any glass of water, not all the molecules are traveling at the same speed. That is the reason we get evaporation, which is really cool.
Right. If they're all traveling at the same speed, they'd either all evaporate or they, or none of them would.
Yes.
With like temperature, what you're getting there is an average.
Yeah.
Right?
Yeah.
Yeah.
since the hotter the water is, the faster the water molecules could be going. So there's a greater spread that any individual molecule could be in, and hence you have more uncertainty about the velocity of any individual molecule, and thus more uncertainty about the total sum of all molecules overall.
Yeah, that's perfect. And I think this is intuitive if you just imagine a glass of water at 0 Kelvin,
Yeah.
right? You know what all the molecules are doing? Nothing.
Mm-hmm.
Whereas if it's 300 Kelvin, you're like, okay, well, there's stuff going on in here with some of these, but do I know, what does it tell me about the molecule next to it? Not much.
And he also makes the assertion that if you know the states of all the molecules in a glass of hot water, you can extract useful work by using your knowledge to take electricity out of it and leave behind an ice cube. The fact that we don't know every single thing about every molecule of water in there is fundamental and important, because once we know those things, we can use that knowledge to do work with it.
Okay, fair enough. I mean, I think I'm following you.
Okay.
I'm curious where this is going.
That's the problem. There's a lot of physics that we went in over just now, and each individual thing I think I can wrap my head around, and I kind of see how some of them are related to others, especially when I read the post and they're kind of laid out with more segues than I put in. But like I don't see how they're related to what is going to be coming after this break right here. Like, this is literally where I put the break in my notes. Like, all the physics above makes sense, I guess. All the epistemics below, believe them, sound good. Don't see how anything relates to each other. And I think they were supposed to relate to each other somehow. And that makes me worry.
Well, it could be, not every post is as clear as others. He talks about Maxwell's demon, which I've heard of, which is like the idea of basically getting energy out of a system where you just put, hot gas into 2 volumes and then only let fast moving molecules go from, one to the other, and then only slow ones from the other one to the other one. But it's like, how do you decide which one's going fast? And so that agent is called Maxwell's demon. I'm sure there's a Wikipedia page for it. So then Yudkowsky says, the reason that you can't build an efficient refrigerator this way is that Maxwell's demon generates entropy in the process of inspecting the gas molecules and deciding which ones to let through. But suppose you already knew where all the gas molecules were, then you could run a Maxwell's demon and extract useful work. So, like, okay, sure. If you knew the perfect state, I'll take your word for it, but what does that have to do with anything?
No.
So then he goes on to talk about bits and entropy and knowledge not being subjective.
Well, that statement that Maxwell's demon is doing important thermodynamic work when it evaluates which gases, which molecules are faster than others, I think is an important part to all this. It's kind of like the linkage between the link between the top and the bottom, but I'm not sure exactly. Because like the next thing I pulled out that was particularly interesting to me was that knowledge has to be represented in a brain. It is not like some mystical spirit thing that's floating somewhere out there. Knowledge doesn't exist aside from being inside a brain, and that makes it as physical as anything else. For M to physically represent an accurate picture of Y, M's physical state must correlate with Y.
Yeah, especially if it has to be an accurate picture.
Yeah.
And correlate with, not be one-to-one with necessarily, right?
Yeah.
Yeah, no, that makes sense. And I think I see where he's going then maybe with the Maxwell's demon thing, because like then I guess the Maxwell's demon here is what, Bayesian inference, creating knowledge from the environment?
He doesn't go that far, at least not yet. The main thing that I pulled out in relation to that is that he says one subsystem cannot increase in mutual information with another subsystem without A, interacting with it, and B, doing thermodynamic work. Which is to say, to form accurate beliefs about something, you really do have to observe it.
Interesting. I guess the "you" isn't italicized there, but really do is, because I don't have an accurate belief about something, right?
Why don't you?
I haven't observed how far away the sun is, but I'll take the astronomer's word for it, right?
That's a good point.
So like I have an accurate true belief, but it's not like my personal knowledge, like in the way that I know what color my water bottle is, but you don't.
Well, if nothing else, you observed what the astronomer said, either through reading text or through hearing them say it, right?
You're right. So in a strict way, I don't know how far away the sun is. I know how far away Neil deGrasse Tyson says it is.
Right. And
Yeah.
you had to observe Neil deGrasse Tyson or somebody to have that belief.
Right. Really, all you have to do, I guess, is put on your Mad Eye Moody thinking cap. And then this becomes more intuitive here. Okay.
And importantly, any such observation requires thermodynamic work because it requires thermodynamic work for your neurons to do anything at all, to change from one state to another, to alter themselves.
Okay. Yeah. I mean, that makes sense. But I'm not doing any of I'm not doing any of the thermodynamic work.
Well, your body is in the process of forming a belief. It must expend energy and create heat in order to change your brain in some way.
Sure. Yeah. Like
Okay.
the same way that like my liver whatever does something to my blood, but I'm not doing anything to my blood. Right.
Right. Yeah.
It's
I
just
think this
it's
is one.
happening to me.
Yeah.
Or in
Yeah.
me.
I think that's what links it back to Maxwell's demon. That Maxwell's demon would use energy of some kind because that's if you're not doing magic, then that's,
Right. You need to be using energy.
required.
Yeah. Okay.
Yes,
I'm with you.
Okay. So forming accurate beliefs requires a corresponding amount of evidence is a very cogent truth both in human relations and in thermodynamics. This is a great line here. If blind faith actually worked as a method of investigation, you could turn warm water into electricity and ice cubes. Just build a Maxwell's demon that has blind faith in molecule velocities.
This does tell me that I have read this post, but it would have been, in the early 2010s because that line rings a bell. But it says something that I don't remember any of the rest of this.
Right. And that ties back to the earlier thing that said, if you do know where all the molecules are, then you can take electricity out and leave behind an ice cube. So if blind faith gives you any real knowledge, then you could use blind faith to do that.
Okay, so what he's saying, the whole point of this post seems to be that forming true beliefs takes actual work.
Yes, in the thermodynamic sense.
Well, and it's kind of uselessly reductive to say it takes thermodynamic work. In my opinion, like I think what he's saying is that like you have to actually do work to get knowledge. It's not enough to just say, well, no, I just know, because if you could just know, then you could, you would be magic, like because you'd be violating the laws of physics.
But I think this actually is an important thing to say because a lot of people do think of knowledge and ideas as non-physical things just intuitively. I feel that way too, so it's good to be reminded that they're not. And specifically, that's why a concept like Maxwell's demon feels attractive, because you're like, why couldn't something just have this knowledge and find these things out? And it's like, because it always takes actual thermodynamic work, and therefore it would not be a perpetual motion machine that turns warm water into ice and electricity. It would be creating waste heat in the process of finding out this information, unless you believe in magic.
Yeah, I mean, I guess that's probably technically true. I guess I'm just thinking about it at a, to me, more useful level of abstraction, which is like, again, my lungs have to be delivering, through whatever mechanisms involved, oxygen to my red blood cells. It gives it to the rest of my body, gives it to my brain. But like, all that really means is that I can't hold my breath forever. And that's the part that I care about, right?
Yeah.
So for me, it's like, what I'm taking from this is maybe not everything he wants me to take, but I'm hoping that it's at least part of it, which is like, there needs to be real work involved in getting knowledge. And if you could get it from nowhere, you'd be magic. And not, so it's not just an argument against like faith. And it might be also that the harder something is to know, the more work it takes. I mean, that's not necessarily actually true, I think, in the thermodynamic sense of the brain, though.
No, because anyone could say something and you could update on it with very little work, even if it took them tons of work to find out the really hard thing in the first place.
Yeah, but maybe to find the hard thing in the first place is the hard work that took lots of like literal energy.
Maybe. The thing that really worries me about this is that I right now feel like I am getting up my own ass about this. That I'm speaking almost some sort of mystic woo, that it feels truthy and it has a lot of sciencey words in it, but I don't fully understand them. And all that very much worries me and makes me worry about hidden divide by zero errors. And I don't want to fall into the trap of, I don't know, becoming another mystical woo-ish hippie person believing that quantum whatever means that crystals work.
Yeah, that's kind of why I'm tossing out all the stuff I don't understand and just running with the easier version.
Yeah.
So it's running with the divide by zero trap there. It's like I'm literally just making the math easier and looking at easier problems so that I can make sure I'm not doing that. So like what I can confidently say is the stuff I've said. I can't confidently restate his actual argument here because I don't understand it.
Well, I think that if we're doing some sort of analysis, critical analysis, attempting to understand the sequences, it may be kind of important to point that out, that this one it seems to just not work, at least for me. And I go ahead.
I was just going to agree. Like there are some sequence posts that I think are more welcoming than others. And again, wanting the community to be welcoming, I want this stuff to be accessible.
Mm-hmm.
Um, this is one, like if I was trying to get my friend, hey, check out how cool rationality is, I would not send them this one,
Yeah.
right? Even if
I
maybe if they were a physicist who really loved everything Maxwell ever did or something, and they were like super into all this stuff,
mm-hmm. Then
but
totally.
even then, it's still like if they ask me like, "Oh, can you tell me more about that?" Like, no, sorry, I can't because I
Now,
don't understand it well enough.
is that a problem for the community though? Because that feels like a Trinity thing. Like, oh, you can't understand the Trinity just yet. Maybe once you get more knowledgeable in the ways of the spirit, or more knowledgeable in the ways of physics and calculus. Like,
Eh,
on the one hand, I understand like writing to the people who need to hear from you, and he's writing to his fellow super mathy calc nerds. But on the other hand, if we're trying to make this a wider thing,
I mean, some stuff is just going to be more complicated. It's like uh,
yeah,
whatever. The world's greatest physicists getting together and talking about stuff are going to be able to have conversations that even other physicists can't follow. It it's I guess I don't think it's a problem for like the movement though or anything like because for whatever it's worth, I've been quote unquote somewhat level of involved in this stuff for like 15 years, and I still don't
yeah,
quite get this right.
yeah.
Um, so I don't think this is necessary, like requisite knowledge to be in the know.
Maybe we need sort of like a Saint Paul to come around, and a Scott Alexander perhaps to make this stuff more explicable to the people who don't have advanced calculus knowledge.
Or realistically too, one of our listeners better understands this stuff and can give us a better analogy that explains what he's trying to get across here. Because
I'm
Dukowski
worried.
is a really good writer, but he's not perfect. And I
Yeah,
think this is an example of because we're not you and I aren't super geniuses, but neither are we stupid, and we don't understand what this is exactly trying to say. Like at the again, because I'm reading the last sentences, I understand where it's getting, but
mm-hmm.
I don't quite understand all this work to get there, other than maybe just kind of like an indulgent way of making the point here at the end.
Yeah.
And then if someone says, "Well, sure," but it's like, "Well, no, actually, because I've just proven with all this other stuff."
That's the part that gets me. Well, I've just proven with all this other stuff, and then the other person is left saying like, well, I can't understand all that other stuff, so I don't know. Am I stuck taking it on faith?
Yeah, that's a valid concern and an interesting worry. I mean, I would make this point differently without talking about thermodynamics and Maxwell's demon. I mean,
Yeah.
I think that the point of this can actually be distilled down to a handful of the quotes, right?
Yeah.
The bold one about to form accurate beliefs about something, you really do have to observe it. That
Mm-hmm.
knowledge can't come from nowhere,
Mm-hmm.
um, and that
Information is stored in brains.
yeah, that knowledge is stored in brains. I mean, it's interesting because like you have knowledge that you don't know you have stored in your brain,
Mm-hmm.
and I don't quite know how that works in this model. I mean, like for example, even though you haven't known until I told you that you can't buy plutonium at Starbucks, you
Right.
know.
Yeah.
But I guess the work of that comes from knowing about plutonium and about what Starbucks is.
Mm-hmm.
So it's kind of just like an inference there, and maybe that inference takes a bit of work. I guess I just don't see this usefully abstracted all the way down to the level of molecules. I see this being useful at the level of facts and truth and knowledge, right?
Yeah. Agreed. Maybe someone can tell us why the invoking of molecules was important.
I look forward to it.
Yeah. So, what is the final thing at the end here that you tried to get to a few times, which I find ironically appropriate?
No, you're good. He says in quotes, "Cold rationality," unquote, is true in a sense that Hollywood scriptwriters never dreamed, and false in the sense that they did dream. Um, so unless you can tell me which specific step of your argument violates the laws of physics by giving you true knowledge of the unseen, don't expect me to believe that a big, elaborate, clever argument can do it either. Maybe
I,
this is actually a satire / self-aware nudge nudge wink wink thing.
oh, maybe it's a test.
He's making this simple point at the end,
Yeah.
uh, but then he gives this whole long, complicated argument about the laws of physics and thermodynamics and stuff
Yeah.
in a big, clever, elaborate argument. Um,
Yeah.
so maybe we're not supposed to believe that. We're if we can't whatever, notice the specific bits that are true, but I think he's talking about something different, and I'm reading into that
No,
incorrectly.
no, man. I love this reading that, 100 years from now, or 1,000 years from now, when the monks are analyzing the scrolls, they will say like, and here he proved by clever joke that you shouldn't believe big elaborate clever arguments by giving a big elaborate clever argument which didn't seem to say much of anything and may have violated laws of physics in it. But you don't know which part violated the laws of physics, so you're stuck accepting it or not.
Yeah, I can dig it. Maybe that's what he's doing, but I'm not sure.
Right.
He probably has many
hope it
purposes
is.
here.
Yeah. And of course, he would never cop to it if he was.
Yeah.
Because that would ruin it.
So I think what he's getting at there too with the quote unquote cold rationality is like cold fusion. It's like knowledge from nowhere. And he's like, that's not actually possible.
Mm-hmm.
And it's not possible for like actual physical reasons, but also just like intuitive and easier to explain, higher level physical reasons,
Yeah.
But
I'm glad we struggled through this and got to the end.
Me too.
And made this, yeah.
I don't think we would have done any better if I had stopped to read it. So
good point. This was probably the best course.
Teaching. All right, well, this ties neatly, I'm assuming, into the next one called Perpetual Motion Beliefs.
I hope it does.
And so he opens talking about, a quote from the last one, that to form accurate beliefs, you really do have to observe it.
He talks a lot about probability of beliefs, and brings up a lottery ticket saying, someone has a lottery ticket that says you can't prove I won't win, which means you may have calculated a low probability of winning, but since it is a probability, it's just a suggestion, and I am allowed to believe what I want. And Eliezer says, yeah, sure. Smash an egg on the floor. The rule that says that the egg won't spontaneously reform and leap back into your hand is merely probabilistic. It's like that glass of water that, could spontaneously form ice cubes and electricity. A suggestion, if you will. So why not just ignore that suggestion? Then the egg will unscramble itself, right?
I like that analogy a lot because, the egg reassembling and flying into the person's hand isn't strictly impossible with the laws of physics.
Mm-hmm.
It's just so unlikely that it'll literally never happen unless you're, got a Tegmark sized view of the universe, right?
Right.
In which case it's happening somewhere at some point, but probably just once. So, it's like, there's I think this is succinctly, maybe not put in this post, but probably in Methods of Rationality and elsewhere, that one must be mindful to distinguish possibility from probability. Right? There is a possibility that when you buy a lottery ticket, you'll win. Right?
Yes.
In fact, there's a very calculable possibility. It approaches zero, but it's non-zero. Now, will you probably win? Now, hell no.
Yeah, I like the way that he put it. It's probability constrains what you expect. He says you cannot expect the egg to reform. You must expect it to smash. Your mandatory belief is that the egg's probability of spontaneous reformations is approximately zero. So even though there is, a possibility, it's not literally zero that the egg will reform, it is mandatory to expect that it won't reform due to that's how probabilities work and how expectations work.
Yeah. There's a line in here that I like too, that probabilities are not logical truths, but the laws of probability are.
Yeah.
What if I guess the state of the boiling water and I happen to guess correctly? Well, then, congratulations. It's like winning the lottery. Your chance of guessing correctly by luck. That was my answer, was the lottery. His answer is better. Your chance of guessing correctly by luck is even less than the chance of the water cooling down in your hand by luck.
Yes.
But you can't prove I won't guess correctly. I can, and indeed must, assign extremely low probability to it. That's not the same thing as certainty, though. Hey, maybe if you add enough wheels and gears to your argument, it'll turn warm water into electricity and ice cubes. I love it.
No. He does point out that, like, when half-trained or 10th-trained rationalists, or I'm going to insert here, people who call themselves post-rationalists but have never touched rationality, when they abandon their art and try to believe without evidence just this once, they often build vast edifices of justification, confusing themselves just enough to conceal the magical steps. There's always some step where a tiny probability turns into a large one, where they try to believe without evidence, where they step into the unknown thinking, no one can prove me wrong. their foot naturally lands on thin air, for there is far more thin air than ground in the realms of possibility. Which is, again, why you must expect thin air. It's just so much more of it than ground.
I love it. I think some part of that must have been in methods of rationality, or just somehow managed to stick in my brain. Right. The part where a step where the tiny probability turns into a large one. That seems to be a failure mode of really anytime anyone who's otherwise smart, goes wrong, right?
Mm-hmm.
We've talked with a couple people who won't exactly say outright that they believe in magic, but act like they do, and then sometimes say they do.
Yeah.
At some point, there's like what I would consider a tiny possibility of like, well, there's this other stuff that's not physics that's affecting the outcomes of things or whatever, right?
Mm-hmm.
I think that's tiny, but to them, it ceases to be tiny. It gets big.
Yeah.
Right? Big enough for them to spend money and change their life around, right?
Mm-hmm.
And so I think, you can't have you got to be mindful of what your probabilities actually are.
Yeah.
Cool. I can dig it.
All right. Well, what are we reading next time then?
I think next time we are doing, there it is, searching for Bayes' structure and conditional independence and naive Bayes.
Excellent. And you got a leg up because you've already read those.
Yeah, but I'll reread them by, next recording. So it'll go faster the next time.